Hello everybody and welcome back to part 3 of our user-defined function session. And so far our function only returned one value, but of course functions can return many values. And therefore we've defined the function calc with the parameters x and y. And our function should return x plus y, x minus y, and x multiplied with y. So let's define the function. And then we can call our function with the arguments 5 and 2. And our function returns us a tuple with our 3 values. So 5 plus 2 is 7, 5 minus 2 is 3, and 5 times 2 is 10. So we get a tuple with our 3 results. And we can do this more explicit by defining a variable. So we can say x plus y is add, x minus y is sub, and x times y is mult. And then we can also return the variables, so add, sub, and mult. So this is our function 2, and we can also call our function 2 with the arguments 5 and 2. And of course this gives the same tuple. And we already learned that we can assign a variable to a result of a function. So we can assign c to the tuple. So c is the tuple 7, 3, 10. And then we can unpack the tuple by assigning the variables add, sub, and mult. So now add should stand for 7, sub should stand for 3, and mult for 10. And we can also do those 2 steps, in only one step, by calling the function and directly assigning the variables add, sub, and mult to the results of our function. So this is the same as above, but we could save one step here. So add is again 7, sub is 3, and mult is 10. Alright. And what we can also do, we can add a conditional if statement in our function body. So we can define, first of all, a list with 7 elements, 1 till 7. And what we want to do then, we want to define the median of our list, so there's no built-in function median. And the median of a sequence of values is actually the value where 50% of the other values is lower and 50% is higher. So the median of our list should be 4. 3 values are lower and 3 values are higher. Yeah, and our median function should cover all cases, whether we have 1 element, 5 elements, or 10 elements in our list, or even no element. So first of all, we define our function median with the parameter x, where we expect a sequence, and then we calculate the length of x. So to say the number of elements in our sequence. And if the length is smaller than 1, so if there's no element, then there is no median. So our function returns nothing. And if the amount of elements in our list is odd, then our function median should return us, actually the middle point here of our list. So in this case, the element at index position 3, so the 4th element. And all other cases where the amount of elements in our list is even, so for example we have 6 elements, then the function median should return us the average of the 3rd and 4th element. Alright, so let's run our function here. And then let's call our function with our list L, so we would expect 4 as the median. And this is true. Alright, so before we learned about generating random integers with the function random.randin, and there we can create random integers, for example here in range 1 till 100. First of all we have to import the random module. And for example here we have 52. But what if we want to create many random integers? Then we need a for loop, and we can also create here a function called random generator, where we have the parameter size. So we want to have 50 random integers, and the lower endpoint is 1, and the higher endpoint is, for example, 100. So 50 random integers from 1 till 100. And we can also set the parameter seed for the random seed. So we should also be able to change the random seed. So this is the function header here. And in the function body, we create an empty list, set the seed with the parameter seed equals seed as defined here in the function. And then we introduce a for loop. So 50 times we create a random integer from the lower endpoint to the higher endpoint, in this case 1 till 100. And we call the random integer random int. And then we append the random int to our list L, and we repeat this 50 times. And in the end we return our list L with, in this case, 50 random integers. And here in this case we set default values. So our default value for the size is 50, for the lower endpoint 1, for the higher endpoint 100, and for the seed 1, 2, 3. So let's run the cell here. And we can also call the function with the default parameters. So this should work here. And here we have 50 random integers in range 1 till 100. And we can also call our function only with positional arguments. So we can pass 10 for the size, 100 for the lower endpoint, 200 for the higher endpoint, and 100 for the seed. So this should work. And here we get 10 random integers in range 100 till 200. However, the best practice, at least for me, is calling the function with keyword arguments. So this is much better to read and understand for everybody actually. So here now we call our function with 4 keyword arguments. So we set size to 10, lower endpoint to 100, higher endpoint to 200, and seed to 100. So actually our parameters or our arguments are the same as above, so we would expect actually the same result of the function. And this is true, so here we have the same results. But as I said before, this is definitely here the best practice to explicitly have the keyword arguments. Alright, so now we are finished with user-defined functions. Yeah, there's much more to learn about user-defined functions, but I think this is a good foundation for our purposes. And I hope to see you in the next session about visualization with Matplotlib.